yak shaving, the seemingly endless series of menial tasks, from setting up environments to dealing with dependencies, allowing you to go down into that rabbit hole where you end up dealing with the complexities and interconnectedness of today's evolving tech estate. Maybe the way to deal with shaving these yaks is to take an approach to platform engineering, because in theory, it makes the development process more efficient and allows teams to focus on creating value rather than getting stuck in the tangential tasks. My name's Hannah, I'm an AWS Solutions Architect, and with Cyrus, Woodside Energy's Developer Platform Lead, we'll be teasing this theory out in today's talk. We'll begin by briefly level setting on what platform engineering is and why customers build and invest in platforms today. Then we'll introduce some new concepts, starting with the Platform Continuum. This covers the various approaches to platform engineering, from AWS native to custom abstractions. Then we'll introduce the Platform Shared Responsibility model. This emphasizes the need to have a clear operating model and delineation of responsibility in order for your platforms to be successful. But so, which approach is right for you? Here we introduce a mental model that'll help you determine where you best fall along that continuum based on your organization's context. And after all that, Cyrus will bring these concepts and mental models to life through the lens of Woodside Energy and their platform journey, answering questions like, why did they invest and which approach was right for them? We'll have the opportunity to see a demo of their platform, the Cloud Native Factory, and hear about lessons learned before we wrap up with some key takeaways. So, let's get started. What is platform engineering? I want to begin today with an insight from a customer, like many in the room. Platforms are what streamline the setup and deployment of applications, empowering developers to get into production significantly faster. Now, this reflection is not just about speed, but about transformation. And specifically in relation to cloud, it's about a discipline that focuses organizations on simplifying broad cloud ecosystems, like AWS, for developers. And AWS services the whole world, from mom and pop stores to global enterprises. And because of that, there is no one way of enabling and embedding cloud into your organization, which is why we see it across a continuum. Starting on the left, we have the AWS native approach. Now, this can be establishing a landing zone with controls using AWS Control Tower, AWS Config, Service Catalog, or it could be engineers using native tools like CloudFormation or SDKs. But this approach requires a level of AWS maturity from your engineers and may very well require you to hire the expensive unicorns we call full-stack engineers. What's often overlooked is that your operating model, your workflows, your ways of working, all need to evolve alongside your technology. And this needs to happen to ensure that you adopt AWS natively and at scale, especially around areas like FinOps, budgeting, operations. But this can be challenging if your engineers don't want to be anywhere near cloud infrastructure. If, like all engineers, they just want to write code. Or if your strategy is to operate across multiple cloud providers or in combination with on-premise. But an even bigger challenge is if you're faced with the reluctance to change your organizational ways of working around the cloud platform. Sometimes the knee-jerk reaction to this can be to build an abstraction on top of AWS. Now we've swung to the right side of the continuum. An abstraction can mask away the complexities of managing cloud infrastructure away from engineers, integrate with existing ways of working, ops workflows, secrets management, approaches to risk, maybe even deliver on the promise of creating a unified engineering experience across AWS, other cloud providers, and on-premises. There are also third-party commercial and open source solutions like Pulumi or Crossplane, and we've got a number of ANZ customers who have invested into building such abstractions in-house. But of course, this doesn't come without its challenges. Mainly, if you're going to take something off the shelf, you need to treat it like a product. This means continuing to invest into your abstraction so that it remains evergreen, keeping up with AWS or the base platform as new services and features are shipped. For example, we recently launched Amazon Bedrock, and if you are consuming AWS through a homegrown abstraction, you need to invest into onboarding and enabling that service into your abstraction layer. But to be honest, these abstractions or these approaches are the extremities of the continuum. And the truth is, for majority of customers, what you'll need exists somewhere in between. Customers can choose to build a slim and lightweight platform, focusing on developer productivity. Give your engineers a friendly means of managing cloud infrastructure. Or you could choose to build one yourself, similar to creating a domain-specific language. And of course, we have the third-party open source and commercial options like SST.dev, which is one that's currently rising in popularity. And native AWS options in this realm include AWS Cloud Development Kit, CDK, AWS SAM, Serverless Application Model, and AWS Proton, which are all services and frameworks you can build your developer platform on top of. We've also seen customers create this two-speed approach to cloud. So deploying legacy applications via the abstraction layer, which might be managing a handful of services, and directing net new developments and workloads for modernization towards AWS native or the developer platform approach. Now, these approaches are not a set of discrete points, but rather fall across a nuanced continuum, where each organization finds a unique point on that continuum based on their cloud maturity, strategy, and requirements, hence the platform continuum. But wherever you might fall on this continuum, you'll be governed by the AWS shared responsibility model. Now, this is a familiar picture to many of us, and it delineates the responsibility between AWS and the customer. AWS is responsible for security of the cloud, so the underlying infrastructure, and customers are responsible for security in the cloud, so your deployed applications and provisioned AWS resources. Now, the introduction of a platform adds another layer into the shared responsibility model, essentially splitting the customer responsibility into two or more parts. So here, the platform team starts to take on some responsibility in the cloud. So this is an example of what a particular platform team is responsible for, but how much responsibility and exactly what that responsibility looks like depends on your chosen approach. For example, if you chose to build that lightweight CDK-based developer platform, you might dedicate a specific team to manage and maintain CDK constructs. But if you're building a deeper abstraction, then the platform team assumes more responsibility, leaving engineering to develop and deploy code via a predefined pathway. Wherever the line of responsibility falls, what's important is that you unanimously agree on a platform shared responsibility model. You communicate it, and you evolve it as your teams mature. You need to draw the right organizational lines and understand how to balance freedom with control. Speaking of freedom, freedom in the minds of engineers means having admin access on your laptops. It means no corporate proxies and having the ability to build and experiment freely within AWS accounts. But there's a balance. A balance between having too much freedom and the subsequent chaos that comes from that, and having too much control, where nothing ever gets done. To keep engineering productivity and velocity high without compromising safety or security, you want to strike within this Goldilocks zone. Regardless of which approach you take, when a company starts to treat their platform like a product, success is found in understanding who that platform customer is. And it's not just engineers. Understanding their requirements and building backwards from them. You need to know whether you're building to provide the most engineering freedom or building to embed risk controls and guardrails. Don't build it and wait for people to come. The success of a platform is found in its adoption and in its usage, so know who you're building for, what they own and what you own, and when balanced well, you'll fall within this platform Goldilocks zone. And this is where you start to pave the way for safe and rapid app deployment. So then, which approach is right for you? Will there be a decision tree or prescriptive guidance to a specific answer? The simple response is no, and GenAI can help you solve for this one. Determining what's right for your organization starts from understanding your organization's context and working backwards from there. It's a deliberate weighing of trade-offs and considerations. So, in this mental model, we propose 5 key questions for you to reflect on, and that'll help guide you along the way. Start by asking yourself, are you an organization of builders, or are you an organization of buyers? Are you planning to grow, hire, invest in full-stack engineers? Is your strategy for AWS to be the sole strategic cloud provider, or will you be operating across a heterogeneous environment? Are you willing to change your operating model and your workflows around the cloud platform, or do you want to keep close to existing ways of working? And lastly, is your organization an outlier with unique compliance and regulatory contexts, or an inlier, mainly residing within industry standards? Ultimately, it's a judgment call. But by reflecting on these guiding questions, you'll start to see where you best fall along that continuum. Let's run through some hypothetical customer examples, and you might even recognize yourself in them. Now, I'm a customer that's building my business from scratch. I want to use AWS as my sole strategic cloud provider in the most frictionless way possible. Initially, I want to prioritize development speed over governance, but know that this might change over time as my business grows. I'll invest in full-stack engineers who not only know how to deploy applications, but also know how to manage cloud infrastructure. Reflecting back to our mental model, here we've got a customer who has a strong team of full-stack engineers building for other engineers. They want to use AWS as their sole strategic cloud provider and are open to changing their ways of working with no unique requirements. Based on this customer's particular context, it's likely that for them, an AWS native approach to platform engineering is the right path. Let's try another example. I'm now a customer that's migrating some applications to AWS, but retaining majority of my existing environment, like VMware and on-premises, in the mid to long term. I want to retain my existing ways of working, including the approach to risk and cybersecurity. And I want to prioritize creating this uniform engineering experience across AWS, other cloud providers, and on-premises. Based on this particular customer's context, they prioritize building a uniform dev experience across a heterogeneous environment. They want to retain their existing ways of working due to the complexity of their organization and have unique requirements built into those existing workflows. So based on what we know and reflecting back to the key questions, it's likely that for them, investing into building a custom abstraction is the right path. Now, for our final example. I'm now a customer that's migrating some applications to AWS and retaining some of my existing environments for the moment. I'm open to changing my operating model around those particular applications, but want to retain my overall organizational approach to risk and cybersecurity. I want to provide my developers this seamless experience on AWS and are leaning towards AWS as my sole strategic cloud provider, but I know that'll take time to get there. In reality, this is where majority of customers will fall, in the it depends zone. You want to provide engineering freedom, but at the same time, you want to keep your existing ways of working. But again, you're open to change, no matter how gradual. But this is why it's ultimately a judgment call, and also why the developer platform approach is the approach taken by majority of organizations.
That definitely rings true for our organization. We sit somewhere in that it depends zone. At Woodside Energy, an internal developer platform is not just a concept, but a proven success story. With over 100 production applications on our platform, with over 200 enabled accounts and close to 2,000 provisioned products, the platform streamlines development, allowing teams to focus on adding business value. These numbers demonstrate the widespread adoption of our platform within the business, which is a great achievement considering that Woodside's not traditionally a software company. Our goal was to implement cloud-native solutions to reduce time to market and total costs while maintaining our strong security posture. However, this shift in development velocity brought new challenges in security, compliance, and sustainability. Rather than depending on a centralized security team to review all applications, we aim to proactively tackle these challenges and make improvements across the board. At the heart of our ecosystem lies Cloud Native Factory, Woodside's internal developer platform, which is essential to the company's strategy, proactively addressing those previously mentioned challenges. Cloud Native Factory is built to empower developers by providing only the necessary features and cutting down on the non-value adding tasks. We continuously monitor deployed applications, validating them against a set of known rules. By prioritizing developers, the platform promotes collaboration between software development and cybersecurity teams, promoting best practices at scale. Here is part of our platform architecture, revolving around three main sections. catalog sharing, provisioning, and compliance. Each part is tailored to address the specific aspects of security, compliance, and sustainability. Now, let's dive into each section, starting with the catalog process. Our platform makes use of AWS Service Catalog to streamline the product sharing. This enables developers to access approved patterns without managing complex infrastructure. We maintain a centralized portfolio of products, which includes custom solutions paired with AWS templated approaches. This definitely speeds up provisioning. Sharing the portfolio from our main account to enabled accounts is simplified by using the inbuilt sharing capabilities of Service Catalog. We also utilize the role-based access controls, eliminating any challenges relating to access and permission management across multiple accounts. When a developer provisions a custom product, events are forwarded cross-account to an event broker, which in return executes an orchestration state machine. Based on the product that is being provisioned, a dynamic set of required resources is queued and executed by an additional step function. This process allows us to orchestrate resources across multiple cloud environments in a fault-tolerant manner. Our platform ensures transparency by automatically checking compliance. We use a compliance as code approach facilitated by AWS config and conformance packs. When an account is activated, config rules are deployed to monitor those provisioned products. Evaluations are forwarded to our compliance service, where we evaluate each product based on that known set of rules. These are forwarded to our status service to be processed. This status is then displayed in our discovery portal. This enables development teams to monitor their application and make sure that they're adhering to Woodside standards. With clear guidelines and less manual work, the platform streamlines compliance across all workloads. Now that we've explored the advantages of Cloud Native Factory, let's deploy an application. In this demonstration, we'll showcase the process of provisioning all the required products to deploy an application following a typical backend for front-end architecture, a pattern that's widely used by Woodside. Let's begin by provisioning a namespace. This is a fast and efficient way to reserve an application space in our cloud environment. By creating this custom resource, we trigger an orchestration process that registers the information in our platform. This helps us track application ownership and deployment accounts. Next, we'll provision a web application product. This is designed to host cloud-native applications. This secure shell simplifies the deployment and management for developers, enabling them to easily deploy their applications into our protected environment without the need for complex configurations or extensive technical expertise. As we launch the product, the orchestration process has started in the background. The initial step functions handle the resource creation process. If we check the resource creation execution, we can see that the primary resources needed for the product are being created. These include DNS, app registration, client registration in our identity provider, S3 access points for static asset deployment, and host metadata that we require in our edge functions. Here's a quick look at the information that we're capturing during the process. Once the product has completed provisioning, we now have all the required outputs for the deployment in the next stages. However, we still need a way to deploy our application. Our next task is to provision a CI/CD connector. This process is faster since it involves a standard CloudFormation template instead of the custom resources we've been dealing with earlier. The connector simplifies the creation of trust policies and IAM roles, which are essential for establishing that secure connection between our CI/CD platform and AWS. By using OpenID Connect, we can replace the need to store long-lived credentials. Instead, we're able to use short-lived tokens for authentication and resource creation. Now that we've provisioned our baseline products, it's time to deploy our application. Let's clone our repository, install the dependencies, and use the outputs from our products. Let's open our workflow file and update our environment variables with those values. With those outputs in place, we can now commit those changes and push them up to our repository. The application deployment has now kicked off, and we're using our assumed CI/CD connector role. We're using infrastructure as code here, so we're able to deploy our entire application stack with a combination of constructs available to us in CDK. This just removes the need for complicated custom scripts. When the deployment finishes, we can access our application in our secure environment. Let's test some functionality, starting with the send message button. It interacts with an internal API that responds with a simple message from hello.api.woodside. Now let's have a look at the introduce yourself button. This sends a simple request to our identity provider, which retrieves all of the information about the current authenticated user. At this point, we're pretty happy with our application. However, it's crucial to review the compliance status and see if we've passed all of our tests. As we head over to our discovery portal, we can easily locate our application. Our compliance system has found an issue with the content security policy. CSPs provide an additional security layer to help detect and mitigate certain types of attacks, such as cross-site scripting. In our current state, our CSP allows any inline JavaScript to run. To address this issue, let's go back to our application code, check out our config. We can see that we've added unsafe inline to our script directive, which should be removed. Let's make the change, push the updated configuration. For some additional context here, the application config enables developers to set security headers specifically for their application in our platform. After updating the configuration and a successful deployment, we'll head back to our discovery portal to confirm the fix. As we check the application status, we can now see that it's passed all the compliance checks, which confirms the fix. This is just a small part of what our platform offers, and it was great to showcase the provisioning of our products, a common deployment pattern, and using our internal tools to solve our compliance issues. But what's the alternative here? Without our streamlined platform, developers could spend anywhere from up to 2 weeks gathering requirements, setting up infrastructure, config roles, permissions, and all while waiting for approvals before tackling the problems that they're meant to be solving. Our platform team's developer-focused, creating products that we'd use ourselves. Our aim is to act as a multiplier for product teams, enhancing their effectiveness at scale. Our platform demonstrates that just with a small team, with typically 4 to 5 developers, you can achieve significant impact. By delivering effective tools and simplifying complex challenges, we boost productivity and efficiency for other teams. And how about some lessons learned that we've across our journey? A common approach in development is to adopt that product mindset, focusing on consistently improving its features based on user feedback. Establish roadmaps ensures that ongoing growth, and it helps align with business objectives. Definitely foster that culture of feedback. However, recognize that accommodating every request is not necessary. If a team outgrows the platform, see that as a success of their product and not a failing of the platform. Maintain that balance between addressing users' needs and adhering to the core vision. Retiring a custom solution in favor of a vendor alternative is definitely encouraged. This ensures that the platform stays up to date with modern tooling and helps it remain appealing to developers who are familiar with those technologies. For example, we made a decision to move away from an internally built CI/CD product to one that was a first-party solution supported by our cloud vendors. High quality and thorough documentation has also been paramount to our platform's success. This enables users to troubleshoot problems themselves. We've seen it reduce support tickets, and it's also streamlined the onboarding for developers who need to get familiar with the platform quickly. And finally, avoid making the platform usage mandatory. Instead, focusing on offering a compelling and valuable option so teams willingly choose it. Highlight the platform benefits such as ease of use, cost efficiency, and time-saving capabilities, which in return can help foster that long-term investment in the platform from the business.
And sharing those lessons learned are key to shaping best practices for the broader community. So today, we'd like you to walk away with 3 key takeaways. 1, approaches to platform engineering are not a set of discrete points, but rather fall across that platform continuum. There is no magic decision tree to output a golden path. It's ultimately a judgment call. 2, know that taking an approach to platform engineering is like managing a product. So know the context of your organization and work backwards from there. It is a balancing act, but by weighing the trade-offs and considerations, they'll help guide you along the way. And finally, from Woodside Energy's journey, know that most organizations fall in that it depends zone, and it's okay. Just know that if you fall into this zone, things will change and evolve over time. So make sure you evolve your platform as your teams mature. With that, as we also talked about the ever-evolving cloud platform and the need to deepen AWS maturity, we've got programs like AWS Skill Builder that help you invest into your self-learning, whether you want to become industry certified or just simply know your apps and workloads a little bit better. But with that, we want to thank you for attending our session today. Please feel free to tap Cyrus or on the shoulder for a quick chat. And if you took anything away from today or have any feedback, please share via the session survey. Again, pleasure presenting to this crowd. Thank you.